Hello and welcome back to the Biochemistry for Health Sciences channel. In today's video, we'll talk about hyperbolic and sigmoidal curves. We shall also see how we can determine Vmax and Km from these curves, and then use the Vmax value to calculate Kcat. In the previous video, we talked about the important steps in enzyme kinetics. So the first is to be able to determine the initial velocity of a reaction that is catalyzed by an enzyme. In the next step, we keep the enzyme concentration the same, but we change the substrate concentration. We increase the substrate concentration. And for each tube, we then measure the initial velocity. So that's a very important step where we determine the initial velocity at various substrate concentrations. So once we have the initial velocity at various substrate concentrations, we now plot the initial velocity V against the substrate concentration S. So here is two sets of data. One is catalyzed by an enzyme E1, and here's the data that's catalyzed by enzyme E2. So we have substrate and initial velocity for enzyme 1, substrate concentration and initial velocity for enzyme 2. So when you plot substrate concentration against initial velocity, we often see two types of curves. One shown in blue here, that is demonstrated by enzyme 1, is called the hyperbolic curve. The second type of curve that we might see, catalyzed in this case by enzyme 2, is called the sigmoidal curve. So let's compare these two curves, the hyperbolic curve with the sigmoidal curve. So let's look at first at a low substrate concentration. When the substrate concentration is very low, you can see for the hyperbolic curve, the velocity increases with the substrate concentration, and this increase is almost linear. So there's a linear increase of initial velocity as the substrate concentration increases for the hyperbolic curve. However, for the sigmoidal curve, as we increase substrate concentration at low substrate concentration, as we increase substrate concentration, you hardly see any increase in velocity. Very, very slow. There's only a little increase in initial velocity as we increase the substrate concentration. As substrate concentration increases for the hyperbolic curve, we now see the loss of that linearity. So we now see this curve here, which means the initial velocity no longer increases in proportion to increasing substrate concentration. So for this hyperbolic curve, this is what we see, the loss in that linear relationship between substrate concentration and velocity. However, for the sigmoidal curve, with increasing substrate concentration, now we see a dramatic increase in initial velocity, and you can see that happening right down here. A slight increase in substrate concentration causes a dramatic, a very large increase in initial velocity. So this is the part that is very different between the hyperbolic curve and the sigmoidal curve right down here. Now at very high substrate concentrations, once we go to very high S, the initial velocity now begins to asymptote. Basically it plateaus gradually and it doesn't increase substantially anymore at all with increasing substrate concentration. The same thing happens for sigmoidal curves. At very high substrate concentration, the initial velocity doesn't increase anymore, and we call this part here where there's hardly any increase in initial velocity as substrate concentration increases, we say that the enzyme becomes saturated with substrate. So the enzyme is working as fast as it can, and it cannot go much faster. Now, since the relationship between velocity and substrate concentration is not linear, we will have to use a statistical analysis method called nonlinear regression analysis. So we'll have to use nonlinear regression analysis in order to determine the two very important values, Vmax and Km, or in case of sigmoidal curves, we also call that K0.5. So let's see how we determine, using nonlinear regression analysis, how we determine these two values, Vmax and Km. So if we use the statistical software, we will see that the Vmax for the sigmoidal curve comes out to be about 100 millimolar per minute for this data. And you can see visually too, that's about where the maximum velocity is, right around here. However, for the hyperbolic curve, visually you see looks like the maximum velocity is somewhere only around 80 or so. However, through nonlinear regression analysis, we actually see that the Vmax is also 100 millimolar per minute, because this curve is gradually increasing with time. It's gradually increasing with time, and that can be picked up by the statistical software. So in both these enzymes E1 and E2, the Vmax is the same, 100 millimolar per minute. The Vmax is basically the maximum velocity that is achieved by the fixed concentration of enzyme. So remember, the velocity is monitored with increasing substrate concentration, but the concentration of enzyme is fixed in all these cases. Once we get the Vmax, in this case 100, now we can determine the Km. So for the sigmoidal curve, once again, this Vmax is 100, we take half of 100, and that is 50, and we extrapolate the 50 to the sigmoidal curve down to the x-axis, the substrate concentration axis, and we get a K0.5, also sometimes called S0.5, of 10 millimolar. So K0.5 or S0.5 for the sigmoidal curve is 10 millimolar. Since the Vmax for the hyperbolic curve is the same, 100, we take half of that. Once again, we get 50, and we extrapolate this 50 to the blue line for the hyperbolic curve and drop it down to the x-axis, and once again we get a value of 10. So the Km for the hyperbolic curve, we use Km. So the Km also comes out in this example to be the same, 10 millimolar. So the K0.5 for the sigmoidal curve is 10 millimolar. The Km for the hyperbolic curve in this case is also 10 millimolar. So what is Km or K0.5? Km or K0.5 is the substrate concentration. This is the concentration of substrate at 0.5 or 50% Vmax. That's the definition of K0.5 or Km. Substrate concentration at 50% maximum velocity. So Vmax and Km are two very important values that we can determine from enzyme kinetics experiments, and these two values, Vmax and Km, in future videos we'll see can give us a lot of very useful information about enzymes. So besides Vmax and Km, there is another very useful value that we need, and that's called Kcat. So let's see how we can determine Kcat. So here's an example problem. So we have got these two sets of data, the same data that we've used before. This data was obtained at a certain pH, at a certain temperature. Remember, enzyme reactions have to be done at fixed pH and temperature values, very important variables to be controlled. Now, we know how much enzyme was added to each tube. Okay, so in this case, 4 times 10 to the power minus 6 molar of enzyme 1 was added to these tubes, and the same amount enzyme for enzyme 2 was added to these tubes. So we know the enzyme concentration. So once we know the enzyme concentration, shown in blue here, and remember enzyme concentration is fixed in all these tubes, now we can use this formula and calculate Kcat. So Kcat is basically Vmax divided by enzyme concentration. So the enzyme concentration is 8 times 10 to the power minus 6 molar, because this unit is molar, while Vmax is in millimolar. So we can convert enzyme concentrations into millimolar, and that comes out to be 4 times 10 to the power minus 3 millimolar. Now we substitute these values and we can determine Kcat. So we have the Vmax. Vmax was found to be 100 millimolar per minute for both cases, for the hyperbolic enzyme as well as the sigmoidal enzyme. Concentration of enzyme in each case was the same, 4 times 10 to the minus 3 millimolar. Divide the two and we get a Kcat of about 25,000 per minute, or we can express it per second by dividing it by 60. So that comes out to be 417 per second. This Kcat is called the turnover number. It basically says that each enzyme molecule, in this example, converts 417 substrate molecules into product molecules per second. So this is called the turnover number. So this is how we can determine Vmax and Km or K0.5 from the hyperbolic or sigmoidal curve, and then use the Vmax value to calculate Kcat. We'll have more videos on enzyme kinetics in the future. So until next time, have a good day, and hopefully we'll see you soon in the next video.